All right, let's talk about a secret that's hiding in plain sight. It powers everything from your online security to, yeah, even your chances of winning the lottery. What is it? It's counting. I know, it sounds simple, but the art of counting all the possibilities out there, what mathematicians call combinatorics, is just packed with these surprising twists, and it's way more powerful than you'd think.
I mean, one, two, three, we've all been doing it since we were kids, right? It feels like the most basic thing in the world. But what happens when the numbers you're counting get really, really big? All of a sudden, the simple little question like, how many, can just explode into this giant puzzle with millions or sometimes even billions of possible answers. Just think about the last time you had to create a new password. You know the drill: letters, numbers, special characters, it's gotta be a certain length. Suddenly that how many question isn't so simple anymore, is it? It's a massive headache. And this is where combinatorics stops being some dusty old thing in a textbook and walks right into our everyday lives. So, how do we get a handle on these gigantic numbers? You'd think we need some kind of supercomputer, but we don't. All we really need is a simple toolkit. And you know what the best part is? It all starts with just two super simple rules. Rules you probably already use all the time without even thinking about it. Okay, rule number one is the product rule. And the magic word you need to remember here is and. This is the rule for when you've got a series of choices to make, one right after the other. If you have to do one thing and then another thing, you just multiply the number of options you have for each. Let's make this a little more real. Picture this. You're in a seminar building. It has 2 floors, and each of those floors has 4 rooms. So to find a specific room, you have to choose a floor and then choose a room. You've got 2 choices for the floor, right? And for each of those choices, you have 4 choices for the room. So 2 times 4, that's 8 total possible rooms. See? So simple, but it's an incredibly powerful idea. All right, our second tool is the sum rule. And if the last keyword was and, this time it's or. This rule is for when you have to make a single choice, but from a bunch of different groups of options. You're picking this thing or that thing, but you can't pick both. When that's the case, you just add up all your choices. So imagine it's your final year of school, and you gotta pick one project. You've got a list of 20 projects from industry, or a list of 10 from your professors, or you could just propose one yourself. Since you can only choose one of those options, you just add them up. So 20 plus 10 plus 1, that's 31 different projects you could possibly choose from. Okay, so we've got our 2 basic rules, and, or, multiply and add. Pretty straightforward. So let's put them to the test with a bit of a brain teaser. How many integers from 1 all the way up to 1,000 are multiples of 3 times or 5? Now, that word or should be setting off alarm bells, right? You're thinking, aha, sum rule. But yeah, there's a little catch. And this is where the trap is sprung. If we just go ahead and add up all the multiples of 3 and then add up all the multiples of 5, we've got a problem. Why? Because some numbers are in both of those groups and we accidentally count them twice. Yeah, take a look at this. It shows you exactly what's going on. Think about numbers like 15 or 30 or 45. Well, they're multiples of 3 and they're multiples of 5. They're sitting right there in that overlap between the 2 circles. So when we just add the 2 big groups together, we're counting all those numbers in the middle 2 times. So how do we fix it? Well, we use this really neat idea called the inclusion-exclusion principle. It's pretty simple, actually. We include the first group, then we include the second group, and then we exclude the overlap that we counted twice. So we take the 333 multiples of 3, add the 200 multiples of 5, and then we just subtract the 66 numbers that are in both groups. And that gives us the right answer, 467. Okay, so we've got our basic tools down, the product rule and the sum rule. Now, we're ready for the main event. This is probably the single most important question in this entire field. It's the one question that splits pretty much every counting problem you'll ever see into one of 2 big categories. And those 2 categories are called permutations and combinations. Sounds kind of technical, but the difference is dead simple. The only thing you ever have to ask yourself is this: does the order of my choice actually matter? So let's talk about permutations first. With a permutation, order is everything. The key word here is arrangement. Think about your password, right? Or the finishing order of a race, or even just the lineup for a team photo. In all of those cases, if you just swap the order of 2 things, you've got a totally new, totally different outcome. You know the classic example? It's the Olympic podium. You've got 150 countries all competing for gold, silver, and bronze. So, does the order matter? You bet it does. The USA getting gold and China getting silver is a completely different result than China getting gold and the USA getting silver. And guess what? This is a perfect job for our old friend, the product rule. We've got 150 choices for who gets the gold medal, and once that's decided, we have 149 countries left for the silver, and then 148 for the bronze. Multiply those numbers together, and you get over 3.3 million possible ways for that podium to look. That's the power of permutations. Okay, now let's flip the script and talk about the other side. Combinations. With a combination, the order is totally irrelevant. We don't care about the arrangement at all. All we care about is the final group, the selection. So think about picking a team for a project or choosing the toppings for your pizza. It doesn't matter if you say pepperoni and mushrooms or mushrooms and pepperoni, right? You get the exact same pizza. So let's go back to our Olympics example, but let's just change the question a tiny bit. This time, we don't care who got gold, who got silver, or who got bronze. We just want to know how many different groups of 3 countries could make it onto the podium. Whoa, look at that. The number is way, way smaller. And here's why. For any group of 3 countries, let's say it's the USA, China, and Japan, there are actually 6 different ways you could arrange them in the gold, silver, and bronze positions. But in a combination, we don't care about that order anymore. So we take our giant permutation number and we divide it by 6 to get rid of all those extra arrangements we don't care about.
And that right there is the perfect illustration of the difference. A permutation is an arrangement where the order is key. A combination is just a selection, a group, where the order means nothing. It all just comes back to that one simple question: does order matter?
And look, this stuff isn't just some abstract math puzzle, you know? These ideas, these principles, they are quietly running in the background of our lives, literally every single day.
Which, you guessed it, brings us all the way back to the beginning. So now it's your turn. Let's look at that password problem. It has to be between 6 and 8 characters long, it uses letters and numbers, but, and this is the key part, it has to have at least 1 digit. So, how many possible passwords are there?
Now, I'm not going to spoil the answer for you, but I'll give you a hint. To solve this, you're going to have to use everything we just talked about. You'll need to figure out the options for a 6-character password, or a 7-character one, or an 8-character one, so that's the sum rule. And to handle that tricky at least 1 digit part, well, you're going to need our good old friend, the inclusion-exclusion principle. And that really is the whole secret of counting. The bigger that final number is for your password, the stronger the lock is on your digital life. You see? These aren't just some random rules from a math class. They're the invisible shield that's protecting your entire digital world. The secrets of counting, well, they're the secrets of modern security.